Okay, this is 12-7, volume of pyramids, cones, and spheres. So we just talked about volume in the last lesson, and we said volume is big B times H. Well, anytime we have a pyramid, a cone, or a sphere, it's going to be volume equals 1/3 times big B times H. So think of this like big B still means the area of the base, but the reason we have 1/3 for pyramids and cones is because they come to one point on top. And it says right here, a pyramid has 1/3 the volume of a prism because it has with the same base and height. So it takes up 1/3 of like a box. So that's where that 1/3 comes from. Okay, so looking at example 1, I don't know where my little tools went, but it says, find the volume of this pyramid, round to the nearest tenth if necessary. So we start with our formula, 1/3 big B times H. Big B means area of the base. The base of this figure is a triangle. So looking at our previous notes, area of a triangle is 1/2 base times height of the triangle. Then we still have times the height of the whole figure. So looking at just the bottom, the base would be 6, the height would be 8. Or if you switch those, it wouldn't matter. Base, height. Then we have the height of the whole figure, which is 5. So we're just plugging those numbers in. So 1/2 of 8 is 4. 4 times 6 is 24. The order doesn't matter when you're multiplying. So they went ahead and did the whole numbers, 24 times 5, then times 1/3. And you get 40. So the volume of this triangular pyramid would be 40 cubic centimeters. So I'm going to have you go ahead and try 1A and 1B to get some practice. Try those, and then I will go over it with you. On 1A and 1B, we are finding the volume of pyramids. So our formula is V equals 1/3 big B times H. Big B means area of the base. So normally it depends on what kind of pyramid, square pyramid, triangular pyramid, rectangular pyramid, on what your big B is, because that means area of the base. But on this, they made it super easy. They literally already told us the area of the base is 90 feet. So in that formula, they already gave us big B. 90 feet squared. Height is 12 feet. So we're just having to plug those in. Now, real quick, if you notice, feet squared times feet means we're going to have cubic feet because it's a 3D shape. So we have 1/3 times 90, which is 30, then times 12. 360 cubic feet is the volume of that pyramid. We don't know what kind, but that's the volume of it. On 1B, they do the same thing. They go ahead and tell us the base area. So they've already given us big B. So I have 1/3. Big B is 25 square centimeters. Height is 12 feet. Oh, I never noticed that. Wait, I maybe just wrote that wrong. I think I just wrote that wrong. They have to be the same units. Okay, so I now have 1/3 times 25 times 12. It comes out to exactly 100 cubic centimeters. Okay, so that would be the volume of that pyramid. Next, we're going to look at a cone. So for the volume of a cone, we have still V equals 1/3 big B times H. Big B means area of the base. The base of a cone is a circle. Area of a circle is pi r squared. So it's going to be 1/3 times pi r squared times H, or height of the cone. This is the formula for that. So when you're taking like your state test, for example, on your formula sheet, they would give you this initial formula for volume. That's it. Then they may tell you, okay, area triangle, area square, area of a circle. But you have to know big B means area of the base and replace it with whatever your base is. Just like on this one, it's a circle. So this becomes our formula. Okay, so like right here, they go ahead and give you these 4. I would write these down. A prism is volume equals big BH. A pyramid, volume equals 1/3 big BH. A cylinder, volume equals pi r squared H. And a cone, volume equals 1/3 pi r squared h. So if you notice, on the prism versus pyramid, the only difference is 1/3 for the pyramid because it comes to 1 point. And the cone and cylinder, same thing. The only difference is that extra 1/3 because it says the volume of a cone is 1/3 the volume of a cylinder that has the same base and the same height. All right, we're going to try one of these. It says find the volume of the cone, round to the nearest tenth. So we start with our formula. Volume equals 1/3 pi r squared h. So on this, we look for the radius, which is halfway across the circle. They give us the radius. So I have 5 squared times the height of the cone is 7. So 5 squared is 25. Then you would do 25 times 7 times pi times 1/3. At this point where they show, you could go ahead and plug all that into your calculator as long as you use parentheses after you do 5 squared first. Plug 25 in there, then you can plug all of that in. When you round to one place behind the decimal, you get 188.3 cubic millimeters. Okay, so let's do, I'll just have you go ahead and do both of them. Do 2A and 2B. Pause the video, and then I will go over it with you. On 2A and 2B, we are finding the volume of a cone. Our volume still starts out 1/3 big B times H. Big B on a cone means area of the base, which is a circle. So our big B becomes pi r squared. Then I still have H. So we take this information we're given and plug it into this. We need R, which is radius. They gave me radius. And H, which is height, they gave me that. So now we are just plugging in. I have 1/3 times pi times radius, which is 6 feet squared, times the height, which is 20 feet. Okay, so we have to do our exponent first. 6 squared means 6 times 6, which is 36. So I have 1/3 pi times 36 feet squared times 20 feet squared. Times 20 feet. So I have, now I do want to say this. All of this is being multiplied. So there's no order on which ones you have to multiply first or which ones you can't multiply first. You want to multiply these two first? That's fine. These two, I would typically do pi last because you're going to have to round with your decimal. But there's no order to multiplying. It's just multiply. You can do it from left to right. It doesn't matter. So I'm going to do 1/3, whoops, if I type it right, times 36. Just because I know that that works evenly. And I get 12. Then I'm going to do 12 times 20 and get 240 pi. So then I do times pi. We're rounding it to one place behind the decimal. I get 753.98. 8 rounds up, so that 9 also goes up. So it actually rounds to a whole number. 754 cubic feet would be the volume of that cone. Okay, on 2B, we're doing the same thing. So since I already know the base of a cone is a circle, I'm going to go ahead and write the formula we're using, 1/3 pi r squared h. Again, they go ahead and give us radius and height. 1 1/2, you could say that that is 3/2, or you could say 1.5. Those mean the same thing. Times pi times 1.5 squared times 9. So 1.5 squared is 2.25 times 9 times 1/3 times pi. So when we round to the 10th place, it's 21.20, 0 rounds down, so 21.2 cubic yards. So that one must have been a much smaller cone to be much smaller of the area. So the last shape we're going to look at today is a sphere. Spheres are their own unique thing. It says the volume of a sphere with a radius r is 4/3 the times pi, the radius of a cube. Radius cubed, excuse me. So a sphere has its own unique volume formula. Volume of a sphere, 4/3 pi r cubed to the third power. Okay, and they show us here with a sphere inside of a cylinder says it's a set of points in space that are given distance r to the center, radius. Suppose a sphere is placed inside a cylinder with the same radius and a height of 2r. The volume of the sphere is 2/3 the volume of the cylinder. So therefore, if you took the height of the cylinder, you would replace it with 2r. That is where they get the formula. If that was really confusing to you, don't worry. All you need to know is that the volume of a sphere is 4/3 pi r cubed. So write that down. And then we'll look at example 3. So it says find the volume of this sphere, round to the nearest tenth. So we start with our formula, 4/3 pi r to the third power. They give us the radius on this, and they tell me it's 8 inches. So I plug that in for the radius. 8 to the third power means 8 times 8 times 8. Then plug all that in your calculator, and we're rounding, so 2,144.7 cubic inches would be our volume. So I'm going to have you just try one of them, just number 3. And this will be the last problem you do today. So pause the video, try that, and then I will go over it with you. Last one, number 3. Now we're going to look at a cube. A sphere. Spheres are unique. They have no vertices, no edges, no lines, nothing. It's just curved the entire way. So it has its very own unique formula for volume. Again, volume is if you were to fill it with something, water, something that would take the shape of that 3D shape. So we're finding the volume of a sphere with a radius of 10 feet. So that formula for a sphere is 4/3 pi r cubed to the third power. Okay, so think of it like there's an r for each dimension. It's 3-dimensional, so there's an r for the flat, then the 2-dimensional, then the 3-dimensional. Okay, so we have 4/3 pi r is 10 cubed. Well, 10 cubed is 1,000. If you forgot how to enter that on your calculator, you press 10, then the little up arrow for what exponent you want. Then when you type 3, that means 10 to the third power. Okay, 1,000. So I have 1,000 times 4/3 times pi. And we are rounding to one place behind the decimal, so we get a very large number on this one. 4,188.79. 9 rounds up, so 0.8 cubic feet. So that is a very large sphere.